Welcome to the lesson MySQL Architecture Overview. When we're talking about how MySQL works, it all starts with connectors coming from our applications. These could be .NET, Python, ODBC, etc. Those are picked up by our server process, which is named, and you'll see it referred to as mysqld. It handles all of these incoming connections and the resulting threads. It has a parser, which receives the raw SQL text that is sent in, validates it, and breaks it down into a parse tree. There are numerous caches and buffers, which are in-memory storage areas that reduce disk I/O and improve performance. These include things like the query cache and the table metadata cache. There's also the optimizer that takes the validated parse tree from earlier and determines the most efficient execution plan. This is where decisions are made, such as which indexes to use and what the join order will be. There's also the storage engine. One thing that is pretty unique and powerful to MySQL and its variants is a pluggable storage engine architecture. You have several options, which allows you to easily adapt MySQL to a variety of uses. More on those in a moment. Separate from the entire server process is the file system on which the actual database files live. MySQL's pluggable architecture separates shared server processes from the storage layer. So the storage engine is responsible for the physical work, reading, writing, and managing data on disk. More on the storage engine options. Our primary one is NODB. It's the default engine that's best for most situations, the go-to relational database engine. This is also the one that we will primarily focus on for this course. MyISAM is a legacy engine, mostly replaced by NODB, although it's still sometimes used for read-only reporting tables. NBD is for high availability, high throughput clustering. It's used when you need data automatically sharded and replicated across multiple nodes with no single point of failure. It is a significant architectural commitment, and MySQL Cluster is essentially a separate product. Memory stores tables in RAM for very fast ephemeral storage, meaning that data is lost on restart. So it's used for temporary tables and reference tables that can be reloaded on startup. It's mostly for fast, small data sets and isn't really feasible for large data volumes or anything requiring persistence. These are some of the top examples, but you're by no means limited to these four, which is part of what makes MySQL so powerful. As for the physical data actually controlled by the storage engine, that's known as the data directory. This contains a subdirectory for each database. It also has system and performance schemas. They're treated just like any other database. This is where your binary and error logs are, as well as NODB system files. And it holds certificate and key files as well. What you'll not see here is configuration files. Those aren't touched by MySQL itself. System-level configuration is kept separate from data files. As I mentioned, each database has a folder within this data directory. So within MySQL, if we have database 1 and table 1, that means there is a database 1 folder within the data directory, and it has a file, a .idb file for table 1. Within that file is stored the rows and indexes of the table, with the rows organized by the clustered index or primary key. Table 2 as well would have its own IDB file with its rows and indexes. It's worth noting that these files do not include things like views, triggers, or stored procedures. Instead, those are stored centrally in the data dictionary. So for example, if we have My Database, there would be a My Database folder in the data directory, and within that folder, we would have files for the employees table, the sales table, and the customers table, each of those stored as a physical .idb file.